Little extra piece here on the form of the null space vectors and how they connect to, I know it's exciting, reduced row echelon form of A. So there's just and it's how we solve it, right? We've said it before. We'll say it a million times. We express the pivot variables in terms of the free variables, right? Blah, 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 blah. And then up will come these vectors that are null space, and we can take any linear combination. And so that's here in the general solution that we just figured out. And more going back in, right, it's here, these two vectors. So they're actually sitting, because of the way this is laid out, they're sitting very nicely in the reduced row echelon form of A. So let me show you that. So here's the reduced row echelon form of A for Fezzik. Let's look at this thing. So I'm going to label the pieces. So this is pivot, free, pivot, free, right? And one thing we've noticed about the pivot columns, and we can ignore this bottom row. So let's take this, take these two. Pivot columns look like this. Squish them together, pull them out and squish them together. 1, 0, 0, 1, which is the identity. Awesome. It's the identity in 2 dimensions, and this is the rank is equal to 2. That's the number of pivot columns. Right? The rank is the number of, yeah, by definition. So that's sitting there. We can also take out, and let me give them a different color, we can take out the, yeah, maybe that's the way to do this. So these colors are here, and then we'll take out the free ones. And that would be 2, 0, minus 1, and 2. So this might seem a little funny. Okay, so they're there. So let's call this matrix F for free. Very good. Our two solutions, where are our two vectors? Here they are, right? Minus 2, 1, 0, minus 2, 1, 0, and 1, 0, minus 2, 1. So let's put them together in a matrix. Let's see what this, our two null vectors, right, that we've used as a, I haven't quite said it, you know, from our earlier solution for the null space of A. Let's stick them together, one matrix. All right, so these are going to be minus 2, 1, 0, 0, and then 1, 0, minus 2, 1. All right, make one matrix. And then let's look at what's sitting here. Well, the identity is here again. This is good. I'm going to use these color things. The identity is here. And it's where the free variables are, actually. So it's flipped, interestingly. Right? So if we label these in the same way, this would be pivot, free, because the null vectors are x vectors, right? A times x. So they match up with the number of columns of A. Groovy. And that's not right. What's sitting in the other one? So in the pivot ones, we have almost looks like F, right? Minus 2, it's minus 2, 1, 0, minus 2. And in fact, it is F, it's just with a negative sign. So these ones here, it's minus F. Which is minus 2, 1, 0, minus 2. Let me write it a better way. It is minus whatever we had up here. So yeah, 2 minus 1, 0, 2. Whereas these ones make the identity. It's plus, it's the normal identity, right? It's not, there's no negative sign there. Okay, so that's good. So what's happening is that this matrix, keep pressing the wrong thing, this matrix times this matrix will be 0, right? The reduced row echelon form times this, and we'll give it a name, we'll call it n. Right, for null, so this is going to be n. So we see that, and you can check this, that reduced row echelon form matrix times n. So what are the sizes of these? So in this case, this is m by n. Well, I don't quite want to take, so this is going to be n, and in fact, well, I'll tell you what it is, but in general, it's going to be n minus r. So we're not up to that yet. But this is equal to the 0 matrix. These things match. It's going to be m by n minus r in general. So this is a secret from later. Secret. Okay. Right. So a times x equals 0. This is the same kind of story. It's a times these vectors. Yeah. Also a times the null space vectors is equal to 0. So that's an important thing, right? The reduced row echelon form of A times a null space vector equals 0. Right? That was the whole story with row reduction. We were changing the matrix, but the solutions were the same. Right. So yeah. Maybe say it here. So A and R sub A have the same null space. Is that helpful? Hopefully it is. It should be. The same null space. And so what's the general story here? So in general, there's some order, right? The x's could be permuted, which is a bit of a funny thing. But basically, so general story is this, is that RA looks basically like the identity, and then this free matrix thing, and there's a bunch of zeros along the bottom, potentially could be many rows, some rows of zeros, and there will in fact be m minus r rows of zeros. Fine. And then there'll be some permutation of this, of the xi's, because, for example, here, right, so the identity matrix wasn't sitting exactly in order, right? Basic idea. And then this null vector will be minus f, if that's the case, and then stacked with an identity matrix here on the bottom. And that will work from block multiplication, RA. This is a little abstract, I realize. It's good for you. If we multiply these two things together, we're going to get I times minus F. So minus I, F, and then plus F times I. These things cancel each other out, and they give us our 0. Right, so it's always true. So you can actually make your null space vectors straight away. It's a little, you have to be a little careful. You don't want to make a mess of it. But what we've done here is, right, we've identified where the identity matrix is. We've identified where the free variable matrix is. And then we swap their ordering, right? So the identity goes where the free variables line up, right? Which is row 2 and row 4 here. And the free one goes here with a negative sign. So you could instantly build it. That will be useful for some theoretical things later on. But that's good. Good.